The withdrawal reflex is an automatic response enacted to withdraw a limb from a painful stimulus. If, for example, you were to touch a hot stove or step on a tack, the withdrawal reflex would cause you to pull your arm or leg away from the painful stimulus without having to consciously plan to do so. The intensity of the reflex is proportional to the intensity of the painful stimulus, so a very hot stove would cause a more rapid and forceful withdrawal than a mildly hot stove. The withdrawal reflex is a polysynaptic reflex, as it uses neurons called interneurons to pass signals from sensory to motor neurons, creating multiple synaptic connections. The reflex begins when a painful stimulus is detected by receptors called nociceptors, which are specialized to detect noxious stimuli. The activation of nociceptors leads to an action potential in a sensory neuron, which carries the signal to the spinal cord, where multiple reflex pathways are activated. One of those pathways excites a motor neuron that activates the flexor muscle in the limb, causing the limb to withdraw from the painful stimulus. Another pathway inhibits the motor neuron that normally activates the opposing extensor muscle in the limb. This will keep the extensor muscle from counteracting the attempt of the flexor muscle to pull the limb away. Another pathway crosses over to the other side of the spinal cord and causes the opposite response to occur in the opposing limb. In other words, the extensor muscle in the opposing limb will be activated and the flexor muscle will be inhibited. This is sometimes called the crossed extension reflex, and it is enacted for postural support. If, for example, you are withdrawing your foot from a painful stimulus, then the other leg needs to be prepared to hold your weight.